10 out of 5. So quick restarter for us. I want you to pause the video, I want you to complete it, and then once you've done that, unpause it because I'm just about to go over the answers. So question 1, name the extraction method used to separate tin from its ore. So if we look at our chemical series, gold found uncombined, silver and mercury, we only need to use heat. Anything between copper and zinc, we would use heat plus carbon or carbon monoxide, and anything aluminium and above, we would use electrolysis. So tin is between zinc and copper, so for here we would just use heat plus carbon or carbon monoxide. Okay, either one of them would have been fine. Question 2, what type of reaction is the extraction of metals? You should know that it's a reduction reaction. It's the gain of electrons, that's what reduction is. Oil rig, oxidation is loss, reduction is gain. So write the overall redox for the reaction involving iron and silver. So if we look at iron and silver here, iron is here, silver is down here. So because iron is higher up, because iron's higher up, that goes through oxidation, and because silver is lower down, that goes through reduction. Okay, so you would write the oxidation, reduction, and your overall redox. Okay, so oxidation is iron. So if we look at iron here, it's going to, well, because it's oxidation, we need to flip the equation, remember. Okay, so oxidation, you flip the equation. So the products become the reactant, and the reactants become the products. Okay, so for this one, it would be Fe solid going to Fe 2 plus aqueous plus 2 electrons. And remember, very important, get your arrows directly underneath each other. Okay, and then the reduction, iron, we just write it as it is. Oh, no, sorry, silver, we just write it as it is. So that's Ag plus aqueous plus E goes to Ag solid. Okay, Ag plus aqueous plus an electron goes to Ag solid. Okay, now we want the electrons to balance out. So what we have to do is this one, we need to times by 2. Okay, and remember, you times the full equation by 2. So that's 2Ag plus 2 electrons goes to 2 Ag solid. Then the electrons can cancel. And finally, we can write a redox reaction. So that's 2 Ag plus aqueous goes to Fe solid, and that is Fe2 plus aqueous plus 2 Ag solid. Okay, and that's it. That's all it is. So, today's lesson, lesson 4 on metals, we're going to look at electrochemical cells. Okay, so before we start talking about that, just need a wee sort of background very quickly on electricity. So electricity, you should know, is a flow of charged particles. Okay, a flow of charged particles. So you've got negative electrons flow through wires. Okay, that's important. They flow through wires, metals, and graphite. Okay, and the reason graphite's the only non-metal, carbon in the form of graphite is the only non-metal that can conduct. Yeah, and then not only can electrons flow through we can have positive and negative ions. Okay, but this time they don't flow through the wires, they flow through solution and molten ionic compounds. Okay, remember it has to be molten or in solution so that the ions are free to move. Solid ionic compounds, if you can remember from bonding, they don't because the ions can't move. Okay, so that's a wee sort of introduction to electricity. We're now going to look at what an electrochemical cell is. Yeah? Now what these do, electrochemical cells, these convert chemical energy, chemical energy into electrical energy. And they're batteries, essentially. Okay, in fact they are. They're batteries. These convert chemical energy into electrical energy. They also need to be replaced when the chemicals are used up. Yeah, if you think of the batteries in your TV remote, eventually that's going to run out and we need to replace the batteries, okay? Exactly the same thing. It's because the chemicals are getting used up. Now, electricity, this is how we can produce electricity. Electricity is produced when two, and this is the key word here, two different, different metals. I'm going to highlight that just to showcase the importance. When two different metals, not the same, two different metals are connected together, are connected together in an electrolyte solution. Okay, electrolyte solution. So, an electrolyte is a solution that conducts electricity. That's what an electrolyte is. Okay, quite easy to remember. An electrolyte is a solution that conducts electricity. Okay, for example, an ionic solution conducts electricity because the ions are free to move. Yeah? So the ionic solution, any ionic solution, would be classified as an electrolyte. Okay? Now, the amount of energy we produce depends on one thing. Okay? So the amount of electricity, well, we'll probably talk about that next lesson actually, what it relies on. But the amount of electricity produced is measured by its voltage. Okay, you would have heard that word before, even if you never took physics, you would have heard it in second year. Okay, the amount of electricity produced is measured by its voltage. Okay, so what we mean by that, the bigger the voltage, bigger the voltage, the more electricity that is made. Yeah, that's all that means. Okay. Now we're going to look at two different types of electrochemical cells. There are two types of electrochemical cells. Okay. Now the first one, it's called a simple cell. Yeah, simple, easy to make, not a lot to it actually. Right, so what we'll have our voltmeter, like that. Okay, probably need a ruler for this. And what we're going to create, what we're going to draw is a beaker, just like so. And inside the beaker, we're going to have two metals, like so. Okay? And obviously from the metals we're going to have wires, so it's going to look like something like that. Okay, something like that. And obviously we need to draw a line for our solution. Okay, a line for our solution. Now, what's important about this? We're going to start labelling it. Remember what we said. Electricity is produced when two different metals. Okay, so if I just call this zinc, yeah, we'll use zinc metal. We can't use zinc here, okay, because if we have two of the same metals, the voltage is going to read 0. Okay, so it's going to read 0, and we'll make a wee note of that there. Two of the same metal will produce 0 volts. Okay, that's the units of voltage, volts. V, yeah, it will produce 0 volts. So I'm just going to make this metal, I'm going to make it different. Going to make it copper. Okay, and in here, this is our electrolyte. That's the solution that they're in. Okay, it's an electrolyte. Now remember what an electrolyte is: a solution that conducts. Yeah, like an ionic solution. So I'm going to use sodium chloride solution. Okay, and the reason this is ionic, if you think back to bonding, sodium chloride, sodium's a metal, chlorine is a non-metal, metal, non-metal, ionic. Yeah? Now, the next part, the last part that you need to know about this is that electrons, okay, remember what we said about electrons right at the start? They flow through wires, metals and graphite. Okay, so we've got metals and we've got wires. So the electrons will flow through the wires. So electrons always flow from the metal higher in the, again, I'm not going to write electrochemical, but you know what it means. Electrons flow from the metal higher in the electrochemical series to the metal lower through the wires. Okay, now I'm going to highlight this because this whole section here is very important. Okay, so electrons always, they flow from the metal higher in the electrochemical series to the metal that's lower. Now, if we look at this, zinc is higher than copper. So what happens? The electrons leave zinc, yeah, and they flow through the wires, yeah, from zinc all the way to the copper. Okay, and that's important. You get asked that quite a lot actually. So they go from zinc through the wires to copper. Okay? So, what's happening here? Because zinc loses electrons, yeah, and the copper gains them, So if we look back at that diagram, yeah, the zinc loses the electrons and the copper gains the electrons. Zinc undergoes oxidation, and copper goes through reduction. Okay, that's why when we did redox equations, that's why the metal higher, we always had to flip the equation because it was oxidation, and the metal lower, we kept the equation the same because it went through reduction. This is why, because zinc loses the electrons and then copper gains them. Yeah, that's what happens. So if we just sort of, I'll do this very quickly. Okay, so if we just do a quick redox equation, you guys should be experts at this. Okay, so zinc, we need to flip. Okay, so that goes to Zn 2 plus aqueous plus 2 electrons. Keep the arrows directly underneath each other, and the copper gains those 2 electrons to form copper solid. Okay, and obviously the electrons are already balanced, so they can cancel straight out. And then finally, Cu2 plus aqueous plus Zn solid goes to copper solid plus Zn 2 plus aqueous. Yeah, and that's it. That's what was happening in that simple electrochemical cell. Okay? Now, next part, again, we used a beaker the last time. Okay, filter paper also works. Okay, so filter paper, you all know what filter paper is. We use it in our filter funnels. So filter paper soaked in an electrolyte will also work as a simple cell. Okay, now if I do this very quickly, we've got our voltmeter here. We've got our, we'll call that metal 1. So what we've got our voltmeter there, we've got metal 1, and we've got metal 2. 2 different metals, remember? Okay, and then they are oh, sorry, made a wee mistake there. That shouldn't, forget that line. Okay. Okay, so we've got 2 metals, yeah, like that, and in the middle, okay, in the middle will be our filter paper soaked in an electrolyte. Now the metals aren't touching. Again, if the metals touch, your voltage will be 0. Okay, so if I just label that there is our filter paper soaked in a solution of sodium chloride. Okay, that also works as a simple cell. Now, more often than not, you're going to get asked about another type of cell. Okay, you're going to get asked about a complex cell. Okay, so simple cell, very straightforward. Complex, a wee bit more to it. Okay, it's a complex cell, and this is what happens when we get two half cells combined. Yeah, two half cells combined. Now, so electricity can be produced this way. So electricity can be produced by connecting two half cells. Okay? Each half cell, so each half cell is made by placing a metal into, and this is important, this bit, I'm placing a metal into a solution of its own ions. Okay, and we're going to highlight that. Okay, so half cell by placing a metal into a solution of its own ions. And you'll see what I mean by that when we draw it out. Okay, so again, here we're going to have our voltmeter, that's measuring voltage in volts. And we are going to draw two half cells. Okay, so that's two beakers, like that. Okay, so two beakers, like so. And in each beaker, we're going to have a metal, like so. Okay, and again, has to be two different metals, but let's just keep it the same as last time, just to show you how it works. So zinc here and copper over here. Okay, now what you'll notice, obviously we've not put in any liquid, any solution yet, but even if we did, this would have a reading of 0. Okay, and the reason we have a reading of 0 is because it's not a complete circuit. Okay, we need to complete the circuit, and you've done this in second year. We need to complete the circuit, so what we use is something called an ion bridge. Okay, an ion bridge, like that. And what that does, if we now add our solution in, yeah, what the ion bridge is doing is completing the circuit. Okay, we're completing the circuit. Now, if we go back to this point here, by connecting two half cells, each half cell is made by placing a metal into a solution of its own ions. Now, what that means, if we take the copper, okay, this solution here has to have copper ions. Okay, so it could be a copper, for example, a copper sulfate solution. Yeah, it could also have been a copper nitrate solution, a copper chloride solution, a copper phosphate solution. Okay, as long as it's an electrolyte, and it would have ions of the metal, so copper and copper are matching up here. Okay, copper, copper. Now, same with this one here. The solution, because it's zinc, yeah, our solution would need to be zinc sulfate, or again, it could be zinc nitrate, it could have been zinc chloride, zinc phosphate. As long as it's an electrolyte and it conducts electricity, But the important part is that the metal has to be in a solution of its own ions, okay? So if we had zinc and tin sulfate, wouldn't work. Yeah, we'd get a voltage of 0. Say we had zinc and magnesium nitrate, wouldn't work. It only works if we've got a metal placed in a solution of its own ions. Okay, and that's very important. It does come up, usually a multiple choice question, but usually it does come up. Okay, now you need to know what an ion bridge is. Okay, so an ion bridge, the purpose of an ion bridge we spoke about, completes the circuit. Okay, now I'm going to highlight that. So an ion bridge completes this circuit. Okay, and how does it complete the circuit? By allowing ions to move between the two solutions. Okay, that's why it's called an ion bridge, because it's allowing the ions to cross, yeah, to move between the copper sulfate solution and the zinc sulfate solution. Okay, now, last wee thing, well, a couple of last wee things, is that electrons, okay, remember what we said right at the start of this when we were talking about electricity, electrons do not travel through the ion bridge. Okay, they don't travel through the ion bridge. It isn't called an electron bridge, it's called an ion bridge. Okay, so the electrons, and again, remember what we said, they travel from the metal higher in the electrochemical series to the metal lower in the chemical series, but through the wires. Okay, so it goes from zinc, because zinc's higher, through the wires, and it will go through into the copper, because that's lower down. Okay, that's what's happening there, yeah? They travel through the wires, okay? Not the ion bridge, the wires. The ions travel through the ion bridge, okay? Now, just last wee thing, and then that's us removing the ion bridge causes the voltage to drop to 0. Okay, so if we remove the ion bridge, the circuit is no longer complete. Okay, and it makes the voltage go to 0. Okay, so the ion bridge completes this circuit. That's the purpose of the ion bridge, and it allows the ions to travel across it. Electrons, they go through the wire. Okay, so let's very quickly recap what we've learned. Electricity is produced when two different metals are connected in an electrolyte solution. Now, an electrolyte is a solution that conducts electricity, so an ionic solution. Yeah? We measure electricity through voltage, and you've got two cells. You've got a simple cell and a complex cell. What's important is that electrons flow from the metal higher through the wires to the metal lower down. Okay, so the metal that's higher goes through oxidation, and the metal that's lower goes through reduction, but you already knew that from the previous topic. Yeah, a complex cell is when you've got two half cells combined. Okay, and what's important about a complex cell when we're combining two half cells is that the metal, the metals have to be placed in a solution of its own ions. So copper is placed in copper sulfate solution. Zinc is placed in zinc sulfate solution. Okay, and then to wrap up, like what we've just learned, an ion bridge completes the circuit, and electrons do not travel through the ion bridge, they travel through the wires. Okay, and that's it. So I'll put up some questions on Teams for us to do, but yeah, that's us, so thank you.